Okay, so let's look at number 2. A drug is supplied as a 40 milligram per milliliter solution in a 50 ml vial. You need to make 10 milliliters of a 10 milligram per milliliter solution. How much concentrate and how much diluent must be used? So we know we need to find the concentrate and the diluent, and we already know what our final volume is going to be. That's 10 ml. So first we need to find how much of the drug we have to put in, and it looks like we are going to be using milligrams. We know our final volume, or desired volume, is 10 milliliters, and the drug comes as 10 milligrams per milliliter. So now we can solve for X. So X is going to equal 100 milligrams. So now we can solve for our volume. Our X is going to be in milliliters. We know how much of the drug we need now, 100 milligrams. And the stock solution, it's supplied as 40 milligrams per 1 ml. And now we just need to solve for X. So 100 divided by 40, and that's going to give us 2.5 milliliters. So we know that that's how much concentrate we need. So we know our concentrate now, and we know our final volume. So we can take 10 ml minus our concentrate, and that's going to give us our diluent. So it's just a matter of being comfortable setting up your proportions to find your grams and your milliliters. Okay, let's go down one and look at number 4. Prepare 10 ml of a 200 microgram per milliliter folic acid solution by using a 5 milligram per milliliter stock solution. How much folic acid and how much diluent will you need? Okay, so first we need to find out how much of the drug we're going to need. So let's set up our proportion, and it's in micrograms. We know that we're going to be preparing 10 ml, and it comes as a 200 microgram per milliliter solution. So now we've got our proportion set up, our units of measure match, we can solve for X. So X is going to equal 2,000 micrograms. So now we can set up our proportion to find out how much volume we're going to need. So X is going to be milliliters, and we know that we have 2,000 micrograms, and it comes 5 milligrams per milliliter. Okay, so here's our problem. We have micrograms and we have milligrams. So let's change the micrograms to milligrams. We're going to move it 3 to the left. So that's going to be 2 milligrams because we have to make sure our units of measure match up. Okay, so now we can solve for X. Two divided by 5, and X is going to equal 0.4 ml. Okay, and we know our final volume is 10 milliliters. So now we already know our final volume, set it right at the beginning of the story problem. We know what our concentrate is, 0.4. We're going to subtract those, and 9.6 is going to be our diluent. So the original question asked how much diluent we need and also how much drug we need. So you can either put 2,000 micrograms or 2 milligrams. Either one would be correct. So the question was worded a little bit differently than the first two, but ultimately we're still trying to find the same information. Okay, let's turn the page and look at one of the actual application questions with the label. Let's look at number 26. Calculate the volume of concentrate used in the following orders. You've been instructed to add 1.5 grams of vancomycin to a 1 liter bag of normal saline. So it's a two-part question. Let's look at A first. How many milliliters of the vancomycin solution shown in the label above will you place in the bag? So we know we're solving for volume. Okay, so we're solving for volume. X is going to equal milliliters. We know the desired amount of the drug is 1.5 grams. And if we look at the label, it says 10 grams, but we don't see milliliters anywhere, so you got to kind of look at the label very closely. And if you turn it to the side, it says each 5 ml of the resulting solution contains 500 milligrams of vancomycin, and each 10 milliliters of the resulting solution contains 1 gram of vancomycin. So there's our information right there. We know that 10 milliliters is equal to 1 gram. So now we've set our proportion up, we can solve for X. And X is going to equal 15 ml. So now that we know our milliliters, and we know how much, if you look at the label, it says 10 grams is equal to, well, it says 10 ml is equal to 1 gram. So 10 grams is, of course, going to be equal to 100 milliliters. And some people may want to do a proportion for that. This one's kind of easy. You can just look at it and sort of figure that out. But we know that the final volume, if we look at B, assuming we have a new vial, and the vial is 100 mils, how many milliliters will remain in the vial after you've prepared the order? So 100 milliliters minus the amount we're going to use or draw out of the vial, and we're going to have 85 milliliters left. Okay, let's do one more. So this one was just a little bit different. Let's go down to number 28. A patient is to take 8 milligrams of dexamethasone in 4 equally divided doses. Each dose is to be diluted to 1 milligram per ml strength and given as a bolus injection every 6 hours. Okay, so two-part question again. A, how many milliliters of the dexamethasone solution shown in the label above will be required to provide the 8 milligram dose? Okay, so we know that we're solving for milliliters. And we know the desired dose is 8 milligrams. And if we look at the label, it says it's equivalent to 4 milligrams per milliliter. So now we have the information to set up our proportion, our units of measure match. We can solve for X. And X is going to equal 2 ml. Now, we're not done. We have to look at part B. How many milliliters will be in each of the bolus doses? So this is our full dose, but we know that we want to break it up over 4 doses. So 2 milliliters divided by 4, and we know that there will be 0.5 ml in each dose. Okay, and that's it. Go ahead and finish working on all of the rest of the practice problems we did not complete together. And if you have any questions, feel free to post them to the Q&A thread or to the virtual office. Good luck!